A load bank is a device which develops an electrical load, applies the load to an electrical power source and converts or dissipates the resultant power output of the source. The purpose of a load bank is to accurately mimic the operational or real load that a power source will see in actual application. However, unlike the real load, which is likely to be dispersed, unpredictable and random in value, a load bank provides a contained, organized and fully controllable load. Consequently, a load bank can be further defined as a self-contained, unitized, systematic device that includes load elements with control and accessory devices required for operation. Whereas the real load is served by the power source and uses the energy output of the source for some productive purpose, the load bank serves the power source, using its energy output to test, support or protect the power source. Applications. Load banks are used in a variety of applications, including factory testing of turbines and engine diesel generator sets, reduction of wet stacking problems, periodic exercising of standby engine generator sets, battery and UPS system testing, ground power testing, load optimization in prime power applications, removal of carbon buildup on piston rings, load rejection test. Load bank types. The three most common types of load banks are resistive, inductive, and capacitive. Both inductive and capacitive loads create what is known as reactance in an AC circuit. Reactance is a circuit element's opposition to an alternating current, caused by the buildup of electric or magnetic fields in the element due to the current, and is the imaginary component of the impedance, or the resistance to AC signals at a certain frequency. Capacitive reactance is equal to 1, and inductive reactance is equal to 2 pi FL. The unit of reactance is the ohm. Inductive reactance resists the change to current, causing the circuit current to lag voltage. Capacitive reactance resists the change to voltage, causing the circuit current to lead voltage. Resistive load bank. A resistive load bank, the most common type, provides equivalent loading for both generators and prime movers. That is, for each kilowatt of load applied to the generator by the load bank, an equal amount of load is applied to the prime mover by the generator. A resistive load bank, therefore, removes energy from the complete system. Load bank from generator, generator from prime mover from fuel. Additional energy is removed as a consequence of resistive load bank operation. Waste heat from coolant, exhaust and generator losses and energy consumed by accessory devices. A resistive load bank impacts upon all aspects of a generating system. The load of a resistive load bank is created by the conversion of electrical energy to heat via high-power resistors such as grid resistors. This heat must be dissipated from the load bank, either by air or by water, by forced means or convection. In a testing system, a resistive load simulates real-life resistive loads, such as incandescent lighting and heating loads, as well as the resistive or unity power factor component of magnetic loads. The most common type uses wire resistance, usually with fan cooling, and this type is often portable and moved from generator to generator for test purposes. Sometimes a load of this type is built into a building, but this is unusual. Rarely a saltwater rheostat is used. It can be readily improvised, which makes it useful in remote locations. Inductive load bank. An inductive load includes inductive loads. An inductive load consists of an iron core reactive element which, when used in conjunction with a resistive load bank, creates a lagging power factor load. Typically, the inductive load will be rated at a numeric value 75% that of the corresponding resistive load, such that when applied together a resultant 0.8 power factor load is provided. That is to say, for each 100 kilowatts of resistive load, 75 kVAR of inductive load is provided. Other ratios are possible to obtain other power factor ratings. An inductive load is used to simulate a real-life mixed commercial loads consisting of lighting, heating, motors, transformers, etc. With a resistive inductive load bank, full power system testing is possible, because the provided impedance supplies currents out of phase with voltage and allows for performance evaluation of generators, voltage regulators, load tap changes, conductors, switchgear and other equipment. Capacitive load bank. A capacitive load bank or capacitor bank is similar to an inductive load bank in rating and purpose, except leading power factor loads are created, so reactive power is supplied from these loads to the system, hence improves the power factor. These loads simulate certain electronic or nonlinear loads typical of telecommunications, computer or UPS industries. Electronic load bank. An electronic load bank tends to be a fully programmable, air or water-cooled design used to simulate a solid-state load and to provide constant power and current loading on circuits for precision testing. Railways, where a diesel-electric locomotive is equipped for dynamic braking. The braking resistor may be used as a load bank for testing the engine generator set.